Hello guys, welcome to our channel at Midboard Tutorial. Today we are going to be continuing our topic composite function, but in this case we are going to be looking at the shortcuts to the examples we did in the previous section. Recall quickly that composite function is simply function of a function embedded into another function. Now if I have y is a function of x, right? If this function of x is now raised to the power of 2, we can see that we have another function that's something raised to the power of 2. In this case, we have the first function, which is a function of x, and we have that function of x raised to the power of 2. So we have two functions, right? Good. So that's why we call something like this a function of a function. Now we introduce the chain rule in solving our example. Today we are going to be looking at the shortcut in doing that. And please, I want you to open your mind. It might look a little bit complicated at first, but it's actually very simple. And once you get a hang of it, you become a star in solving composite function. Now I have same with my last section. I have y is equals to 2x minus 1, everything raised to the power of minus 2. The first thing you need to do is to identify your outermost function, your functions, right? We have two functions here. We have f of x, that we have 2x minus 1, first function. Then the second function is something raised to the power of minus 2. Is that okay? Good. What you now look for next is your outermost function. Which is my outermost function? My outermost function is something raised to the power of minus 2. So it is that outermost function you differentiate first. Is that okay? Good. Differentiating that, we have minus 2 times, is that okay? Because normally our differentiation states that if we have a raised to the power of x, the raised to the power multiplies the base value, right? To give this, then we subtract 1 from the raised to power. That's exactly what we are going to be doing here. So minus 2 multiplies this whole base value. Is that okay? To give what? To give 2 minus 2 times 2x minus 1. Then we subtract 1 from the raised to power. Is that okay? Simple. Now what do we do next? After you've in this case we've differentiated our outermost function to give this. We go into the innermost function, the next function, in this case, which is what? 2x minus 1. And of course, you know, if you differentiate 2x minus 1, we get 2. And that is it. You've gotten your answer. You just multiply 2 times 2 give us minus 4. And you have 2x minus 1, everything raised to the power of minus 3. And we've gotten the answer to this number 1. Is that okay? Wonderful. Let's go on to the next question and apply our shortcut. In the next question, you remember the steps. You have to know your functions. How many functions do we have here? We have the first function, which is minus 4x, and the second function, which is exponential of something. Is that okay? So now we have to the next step is to know the outermost function. In this case, the outermost function is exponential something. Is that okay? Exponential something is our outermost function. Minus 4x, which is our second function, was embedded into exponential something. Is that okay? So this is the innermost function. So what do we do in derivation? We want to derive this. What do? We go to the outermost function here first and we find the differential. And remember I told you in the last section that if we differentiate exponential something, what will it give us? It will give us exponential that thing. Is that okay? That's why I have my exponential minus 4x. Good. We've differentiated the outermost function. Let's go into the innermost function. The innermost function here is minus 4x. If we differentiate minus 4x, we get minus 4. And that is it. We've gotten the solution to this composite function using our shortcut. Very slick, right? Wonderful. Let's go on to the third example. If you compare the results of using this shortcut with the last section, you see we are getting the same answers, but in a very short period of time. In fact, you can solve 10 questions in less than a minute if you actually understand what the shortcut I am doing here. Wonderful. Look at this third question. It says y is equals to 6 over that. Now of course we can write this as y is equals to 6 2x plus 1, everything raised to the power of minus 2. In the last section I explained how to get from here to get this. Is that also good? Now we have this matrix of a question, this um, question that looks difficult, you can actually solve it using our shortcut also. Now remember our steps. If you are looking for the y prime, which is also the y dx, we have to know our first function. 6 here is a constant, right? Why is it a constant? Because it doesn't have our variable x. Is that okay? But since it's still multiplying, we don't take it as 0. Is that okay? Good. Our first function is 2x plus 1, which is the innermost function, right? And it was embedded into something raised to the power of minus 1 over 2. So this is the second function and the outermost function, right? So we have to deal with the outermost function first. And the outermost function, if we have 6, we bring out our constant. Then the outermost function, minus 1 over 2, we'll have to multiply our base, right? So we have minus 1 over 2 times our base, which is 2x plus 1. Is that okay? Then we subtract 1 from our raised to power. That's minus 1 over 2 minus 1. Is that okay? So we've differentiated the outermost function. Then we go to the innermost function, which is 2x plus 1. If we differentiate 2x plus 1, what do we get? We get 2. Is that okay? If 6 opens this bracket, 2 here 1, 2 in 6 here will give us 3, right? So we have our y prime to be equals to 3. 3 times minus 1 will give us minus 3. Then our function 2x plus 1. Is that okay? Everything raised to the power of minus 1 over 2 times 2. If we multiply 2 to it, we get minus 6 dot 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 dot. That's minus 6 without. We get this. Is that okay? We get this our value, and that is the simple shortcut to finding the derivation of composite function. I hope you understand this shortcut. Thank you for watching. Thank you for listening. Make sure you like, comment, and subscribe to our channel below. If you also have any question, you can also type it in the comments. Anything you do not understand, you can put it in the comments. Any video you want me to make concerning this derivative of the composite functions with the shortcut, you can write it down in the comments below. Thank you for watching.